Okay, so in this video, I'm going to go over the Exam 1 review questions. So these are the questions that you can expect to see on your exam, and of course the practice exam. So hopefully you're going to utilize the resource of that practice exam. It is for a quiz grade, so make sure you do it. It's not optional. And you can take that practice exam as many times as you want to practice. And if you're in my online class, just remember, if you're making a flashcard, you need to send me a picture of your flashcard through email so I can approve and let you know if the flashcard is okay. And you can have any formulas or notes, but no worked out examples. Okay, so in this first section, it's about linear equations and linear functions. So number 1 says to graph the equation using the slope and the y-intercept. So if we need to use the slope and the y-intercept, then we want to get it in slope-intercept form. So that is the slope-intercept form where the number being multiplied in front of the x is equal to the slope, and the b, the constant being added or subtracted, is the y-intercept. So we need to solve for y. We need to get y by itself like it is in this form. So first step is to solve for y. So I'm just going to rewrite the equation here. And the first thing I would do to start to solve for y is to subtract x to both sides. And then I'll bring down the negative 2y that's left on the left. And then I'm going to write the right side as negative x plus 8. So I'm going to write the negative x first so that it's closer to being in this slope-intercept form. And then the last thing I'm going to do is divide by negative 2. Divide everything by negative 2 to cancel it on the left. And so that leaves me with y equals negative x divided by negative 2. That'll give me a positive x over 2, or positive 1/2 times x. It's the same thing. And 8 divided by negative 2 is negative 4. So now I have this equation here in slope-intercept form. So my slope, which is the number being multiplied in front of the x, is 1/2. And the y-intercept, which is the number being subtracted here, and I want to include that sign, so the y-intercept is negative 4, and as an ordered pair, that would be 0, negative 4, because it's the y-intercept, so it's on the y-axis, which means x is 0. So now to graph this, the first thing I would do is graph this point first. So I need to start with the y-intercept, so that's 0, negative 4, which would be down here, at negative 4 on the y-axis. And then I use my slope to find the next point. So slope is rise over run. So because the 1 is on top and it's positive, that means I'm going to go up 1, or I'm going to rise 1. And then the 2 is I'm going to go to the right in the positive direction for x. So from the y-intercept, I'm going to count up 2, and then to the right 1 from there. So the little red dots are just me showing you how to get to the next point. I went up 2, or I'm sorry, I did that wrong. I did that backwards. I said up 1, sorry. I need to go up 1 and then to the right 2, 1, 2. So I went up 1 and then I went to the right 2. And so that ended me up right there. That's where I ended up. And now I connect those 2 points, and that would be my line. So everything in red is just me showing you how I got there. But the blue points are the actual points I would graph in Pearson. Okay, number 2 says to write a slope-intercept equation for a line with the given characteristics. So they tell me that the slope is -2/5, and then it passes through the point -2, -5. So remember, to create an equation for a line, you need to have a slope and at least a point. So they're giving me that. And then there is the point slope form of a line, which is what we can use to plug this information in to find the equation of a line. And that is given by y minus y1 equals the slope times x minus x1. So we had the slope-intercept form up there where y is by itself. And that's useful to be able to tell the slope and the y-intercept. And then we have the point slope form of a line. And this is useful to find the equation of a line if we're given a slope, which we are, and if we're given a point that's on that line, which we are. So this is -2, -5. The -2 will be my x1, and the y will be my, or the -5 will be my y1. So I'm going to plug that information into this formula. So that will give me y minus, and then y1 is -5. So that will give me a double negative there, because the minus here comes from the form, and this -5 comes from the fact that this is -5 for y1. Equals the slope, which is -2/5, times x minus x1, which is -2. So again, another double negative. So when we have those double negatives, that changes to positive. So the left will become y plus 5 equals -2/5 times x plus 2. And then I have a fraction, so I can clear the fraction by multiplying everything by that denominator of 5, since that's the only denominator I have. So I can multiply this side by 5 and this entire side by 5, because when I do that, this 5 and this 5 will just cancel, because 5 divided by 5 is 1. That's why we multiply equations by the common denominator to clear fractions, because it can divide into that. So 5 divided by 5 is 1. And that would just leave me with -2 on the right times x plus 2. So I wouldn't have to multiply that 5 by everything because it's all being multiplied. So I only need to multiply it by the first fraction. And then on the left side, I can distribute that 5. And that would give me 5y plus 25. And now I just up here, let me back up a little bit. It wants me to write my answer in slope-intercept form. So I already wrote that above, but the reason why I'm doing all this now is because slope-intercept form is y equals mx plus b, like we just said from the first problem. So now I'm taking steps to solve for y. So I had to use the point slope form to plug the information in, and then I solved that for y to find the slope-intercept form. So continuing on with that, I'm going to subtract 20. Oh, sorry. Actually, I'm going to distribute the -2 on the right first. So that'll give me -2x minus 4. Then bring down the 5y plus 25. And now I will subtract 25 to both sides. And that will leave me with 5y equals to -2x minus 29, because -4 minus 25 is -29. And then I will divide everything by 5. So y equals -2 over 5 times x minus 29 over 5. And this would be the final answer because I solved it for y, and so it is in that slope-intercept form. And if you do end up watching this video and you're confused about anything I do in this video, please send me an email and reach out to me, and we can set up a quick Zoom before you take your test, and I can explain it in more detail. Okay, number 3 says to find the zero of the linear function. So whenever it asks you to find the zero of a function, you're going to take the function on the right and set this equal to 0. So really we are replacing this f of x with 0. I'm setting this whole function equal to 0, and then I'm going to solve for x. So I would add 13 to both sides to cancel it on the right. And 0 plus 13 is 13. Bring down my -4x. And then divide both sides by -4. So x is equal to 13 over -4 or -13 over 4. They mean the same thing. Doesn't matter where you put the negative in a fraction. So that's it. That's the answer to that problem. So make sure you spend time and understand this problem, because this should be a pretty easy problem on the test. And it says to ask, when it asks you to find the zero, you just set the function equal to 0 and then solve for x. Excuse me. Okay, number 4 says that Adams Lumberyard has 500 yards of fencing with which to enclose a rectangular area. So first of all, I'm going to draw a picture here of a rectangle. And since they're using the 500 yards of fencing to enclose this rectangular area, that means the entire edge around the rectangle will be fenced in with that 500 yards of fencing. And this is the perimeter of this rectangle. So the perimeter equals 500 yards. Because they're telling me that they're using that total 500 yards of fencing to go around this rectangular area. And then it says if the enclosed area is x yards long, so that means that here's the length, that would be equal to x. That's what they're telling me. The length is x, because it's X yards long. And then it wants me to express its area as a function of its length. So first of all, I know that the area, and again, it wants to express the area as a function of its length. So the length is X. So that's why I'm writing it like this in function notation. Area of X, or A of X, equals, and the area of a rectangle is equal to length times width. But we were just told that the length is equal to X, so this would be X times W. But we don't know what W is yet. We don't know what the width is. So we actually need to find an expression for the width using the information about the perimeter. So the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. And we know that the perimeter is 500 yards. And that the length is equal to X. So this would be 2 times X plus 2 times the width. So now I have some information and an equation that I can solve for W. Because if I get W by itself, everything on the other side will just be numbers and then the variable X. So then I can plug that into this W. Because whenever it says express the area as a function of its length, that's the only unknown variable they want in the equation. So I don't want this W, I want it to be in terms of X, which is the length. So I'm going to subtract 2X to both sides first, to cancel it there. Then that will give me 500 minus 2X on the left equals 2W. And then I will divide everything by 2. $500 divided by 2 is 250. Negative 2X divided by 2 is negative 1X. And then this, it will be equal to W. So now I have W by itself. So W, which is the width, is equal to 250 minus X. So then I can take that 250 minus X and plug it into this W. So now the function of the area of this rectangle would be the length, which is X, times the width, which is 250 minus X. And I think it'll ask you to simplify this, so you'd want to distribute that X to get 250. That's weird. Sorry. 250X minus X squared. So that is the final answer. Okay, number 5 says Amy has a choice between receiving a monthly, Amy has a choice between receiving a monthly salary of $1,400 from a company or a base salary of $1,100 and a commission on the amount of furniture she sells during the month. And then it says, for what amount of sales will the two choices be equal? So right away, I can identify what they're wanting me to find. The amount of sales for which the two choices will be equal. So whenever, whatever they're asking you to find, that's what you're going to make your unknown variable. So let me say X will be the amount of sales that she sells in a month. And I want to find the amount of sales, the specific amount of sales where the two options or choices will be equal. So I know I'm going to set up an equation where on the left will be the first choice and on the right will be the second choice. So I would take those and set them equal to each other and then solve for X to find the amount of sales that makes them equal. So the first choice was that she can receive a monthly salary of $1,400. The second choice is that she gets a base salary of $1,100 and a 4% commission on the amount of sales. And remember, we said that the amount of sales is X. So this would be the base salary, which is what she makes every month regardless. So $1,100 plus the 4% of commission on the amount of sales, which would be X, or 4% of X. And so to write this mathematically, I would have to change that 4% to a decimal, to 0.04, and multiply it by X. 4% of a number is when you multiply them together. So now I have this, sorry, let me do this. I have this equation down here that I can solve for X now. So I'm going to subtract both sides by 1,100. Which will give me 300 on the left. 1,400 minus 1,100 is 300. And then that'll leave me with 0.04x on the right. And then I will divide both sides by 0.04. So therefore, X will be equal to $7,500. So that's the amount of sales she would have to sell in a month in order for these two choices to be equal. Okay, and then I'm going to upload this file. So I have the inequality rules here again. And again, if this is the first video you're watching, then I will remind you that there is files that I've been posting under the Files tab in Canvas that has the notes that I go over with my in-person students. And it also has the notes from the videos I've posted from Chapter 2. But these are in there, and they're going to be here as well. So these are your inequality rules. So that's the next section, which is solving linear inequalities. In this first example, this is a compound linear inequality, which means it has two inequality symbols here. So technically there is three sides of this inequality. And my goal when solving this is to get X by itself in the middle. So I want to take steps to get X by itself, which means the first thing I would have to do is add 2 to cancel that -2. But because this is a compound inequality, I have to add 2 to all 3 sides to keep it balanced. So then I would bring down, and let me erase some of this. I would bring down my 3x in the middle. That was left. Bring down my inequality symbols. On the right, 13 plus 2 is 15. And on the left, negative 5 plus 2 is negative 3. And then I would have to divide each side by positive 3 to get rid of that 3 in the middle. So x would be less than or equal to 5 or greater than negative 1. Now remember, if you do divide all 3 sides by a negative number, you have to flip your sign. But we didn't divide by a negative here, so I didn't have to flip my sign here. Okay, so on a number line, anytime you have a compound inequality like this, once you get x by itself, it's saying that x is in between these two numbers, negative 1 and 5. And it can equal 5, but it cannot equal negative 1. Because the inequality symbol right here has a straight line under it. So that means it can equal 5, but the other one does not have it, so it cannot equal negative 1. So on a number line, I would have negative 1 and 5. And on the negative 1, this would get a parentheses because it cannot include negative 1. But on the 5, that would get a straight bracket because it is included. And then I would just shade in between these two numbers. So any number in between there would be true for this inequality. For example, 0 is in there because 0 is between negative 1 and 5. 0 is greater than negative 1, so that's true. And it's also less than or equal to 5. So all the numbers in between there in the shaded blue part makes that inequality true. And in interval notation, this would be from negative 1 with the parentheses to 5 with a bracket. And that comes directly from that graph. If you read it from left to right, it starts in the blue with the parentheses. So does this interval at negative 1. The comma represents everything in between that's being shaded. And then it goes to positive 5 with a bracket. So if you can figure out how to graph it on a number line, it's easy to get your interval notation from the image of the number line. Because it's exactly the same as when you read the graph from left to right. Okay, number 2 says to solve and write interval notation for the solution set, then graph the solution set. So this is another inequality problem, and it is a compound inequality because there's 2 here, but this one is being separated by the word or. So this is a conjunction. Which is just the type of the compound inequality. And with or, it means we're going to include everything that's within the solution. So we would include everything from the first solution and everything from the right solution. So I'm going to solve both of these separately first. So on the left side, I want to get this x by itself. So I could subtract 2 first to both sides, which will leave me with 6x on the left, less than or equal to -7. And then I divide both sides by 6. So x would be less than or equal to -7/6. And then on the right one, the right side, I would add 2 to both sides to cancel it on the left. Which will leave me with 3x is greater than or equal to 7. Or I'm sorry, 8. And then I divide both sides by 3. So x is greater than or equal to 8/3. I'm going to bring down my word. So on a number line, I will plot these two numbers, -7/6, and then a +8/3 would be somewhere over here. So for the -7/6, it says that x is less than or equal to -7/6. So that would be a straight bracket because it can equal -7/6. And we'd be shading to the left because it's everything less than this number. And then the other one says x is greater than or equal to 8/3. So that would also be a straight bracket at 8/3. And then we would shade everything to the right because that's everything greater than that fraction. And because this is an or, I would include both of these. Excuse me. So for interval notation, like I said, if you just read the graph from the shading from left to right, it's starting all the way over here, goes forever to the left to -infinity. So it starts from -infinity, which always gets a parentheses. And then it goes up until -7/6 with a bracket. So that's the first interval here in blue. And then I need to hop over this whole part. And so I use my union symbol, which also means to combine two intervals. And then I start at the +8/3 with a bracket, and that goes off to +infinity. So that's my answer in interval notation. Okay, next section is about functions and function notation. So this problem, number 1, is giving me the function g of x is equal to 2x squared minus 3x plus 12. And they want me to find all of these. So for A, that would be g of 0. So that tells me to plug in 0 everywhere I see an x. So this would be 2 times 0 squared minus 3 times 0 plus 12. So the first two terms cancel out because anything times 0 is 0. So this would just leave me with 0 plus 12, which is 12. And then for B, this would be, they want me to find g of -2. So now I'm replacing all the x's with -2. So that would be 2 times negative 2 squared minus 3 times negative 2 plus 12. Negative 2 squared is a positive 4. 4 times 2 is 8. Negative 3 times negative 2 is a positive 6. Bring down my plus 12. 8 plus 6 is 14. Bring down my plus 12. And this will be equal to 26. Make this a little smaller. And then C wants me to find g of negative x. So now I'm replacing all the x's with negative x. So this would be 2, equals 2 times negative x all squared. Make sure you put the negative x in parentheses because we're squaring the entire, whatever we're plugging into x will be squared. So if we're plugging negative x in, the negative part also needs to be squared with the exponent. Minus 3 times negative x, and then plus 12. So whenever I raise a negative number or variable to an even exponent, it becomes positive. So this would become positive 2x squared. Negative 3 times negative x will become positive 3x. And then bring down my plus 12. And that will be it for that, for C. And then finally, D is the hardest one. This is the one that students seem to have the most trouble with. Finding g of 1 minus t. So I'm plugging 1 minus t into x everywhere I see an x, or into g of x everywhere I see an x. So this would be 2 times 1 minus t all squared minus 3 times 1 minus t plus 12. And right here, 1 minus t all squared means I have to FOIL that out because that's the same thing as 1 minus t times 1 minus t. So go ahead and write it out like that, and then I'll distribute this negative 3, which will give me negative 3, because negative 3 times 1 is negative 3. And then negative 3 times negative t is a positive 3t. And then bring down the plus 12. And then I will FOIL this. So I'm going to leave the 2 out here and put my answer from my FOIL in parentheses so I can multiply the 2 in afterwards. So when I FOIL, 1 times 1 is 1. 1 times negative t is negative t. Negative t times 1 is negative t. And negative t times negative t is a positive t squared. Then I can also go ahead and combine these like terms, negative 3 plus 12, which will be plus 9. Fix that. And then bring down my plus 3t. And then in here in the parentheses, I have like terms, negative t minus t That'd be negative 1 minus 1, which is negative 2. So that would be negative 2t. So let's bring everything else down. 2 times 1 minus 2t plus t squared plus 9 plus 3t. And now I can distribute this 2. Which will be 2 times 1 is 2, and then minus 4t plus 2t squared. It's just me multiplying everything by 2. Bring down the plus 9 and the plus 3t. Then I will combine like terms. I can go ahead and write the 2t squared first, just because it has the highest exponent. And then I will combine negative 4t and positive 3t, which will give me negative 1t, which would just be negative t. And then 2 plus 9 would be 11. So this would be the final answer. So it's very tedious. You have to make sure you're taking your time and checking every step. And don't forget any negatives. Okay, the second one says, given that h of x is equal to x minus 2, and g of x is equal to square root of x minus 3, find g plus h of 3. So this is telling me to add the two functions together and plug 3 in everywhere I see an x. So this is the same thing as g of 3 plus h of 3, which tells me to plug 3 into g. And then add it to the result of plugging 3 into h. So g of 3 is the square root of x minus 3. So if I plugged 3 in for x, that'd be 3 minus 3. And then plus h of 3 would be, h of x is x minus 2. So that would be 3 minus 2. So sticking with the colors, this is from h. And this is from g. I'm adding these together. And so 3 minus 3 is 0. So that'd be the square root of 0 plus 1. 3 minus 2 is 1. Square root of 0 is just 0. So this would just be equal to 1. Then the next part wants me to find h over g of x. And then find the domain. So h is x minus 2, so that would go on top. Then divide it by g, which is the square root of x minus 3. And that's it. That would be my answer. I'm just taking h of x and dividing it by g of x. But now it wants me to find the domain. So I need to think about the restrictions on this function. And remember, I told you two restrictions. We can't divide by 0 in a function, and we cannot take the square root of a negative number. So because the denominator of this fraction is a square root, this actually has two restrictions. The first, let's deal with the square root. The expression underneath the square root, which is x minus 3, has to be greater than or equal to 0 because it cannot be negative because it's under the square root. So if it's equal to, that's just that restriction because of the square root. But the second restriction is that the entire thing here, x minus 3, the square root of x minus 3 cannot equal 0 because it's in the bottom of this fraction. So if I solve for the first inequality by adding 3 to both sides, this would tell me x has to be greater than or equal to 3. But because of the second restriction, the only value that will make this 0 would be 3, because 3 minus 3 is 0. And it can't equal 0. So this tells me x cannot equal 3. Because again, if I plugged 3 in here for x, the denominator would become 0. 3 minus 3 is 0. Square root of 0 is 0. And we can't have that. We cannot divide by 0. So combining these two, it says x, the first one says x can be greater than or equal to 3, but we just said that x cannot equal 3. So the final domain would actually be x is strictly greater than 3 and not equal to 3. Just only all numbers that are greater than 3. So in interval notation, this would be starting at 3 with a parentheses and going to positive infinity. This represents all numbers that are greater than 3. Okay. Okay, and then the next one wants me to find g over h of x. So this time, g of x will go on top of the fraction, which is the square root of x minus 3. And then h of x will go on the bottom of the fraction, which is x minus 2. And that's it. I can't do anything else to simplify that. But to find the domain, this equation also has two restrictions. So the first one is same thing as the rest. X minus 3 has to be greater than or equal to 0 because I have the square root. That's one of my restrictions. That expression under the square root has to be greater than or equal to 0 because it can't be negative, which means it can't be less than 0. And then the second one is that denominator, x minus 2, cannot equal 0 because it's in the denominator of the fraction. So we can't divide by 0. So that whole denominator, x minus 2, cannot be equal to 0. So we already know the first one, we get x is greater than or equal to 3. If I solve that inequality for 3. And then the second one, the value that would make that equal to 0 would be 2. 2 minus 2 is 0. So x cannot equal 2. So to write this in interval notation, we can first graph it. I would have 2 here, 3 here. So it can't equal 2. So that would have an open circle. And then the other one says x has to be greater than or equal to 3. So that would have a straight bracket at 3 and be shading to the right. So the interval on the right already excludes 2 because it's all numbers greater than or equal to 3. So I don't even need to worry about the 2 because my domain will just be the interval from 3 to infinity. Because that already does not include 2. So if that was my domain, then I'm saying x cannot equal 2 because it has to be greater than or equal to 3. Okay, and I'm going to stop this video here and finish the second part in the morning. It's because it's really late and I am tired, as you can probably hear me yawning. So I'd like to finish with a little bit more energy, not bore you guys. So I will finish the second part of the video in the morning and upload that and the notes. So look for that, and they will both be uploaded by tomorrow, which is Saturday. Good luck studying, and remember to email me if you have any questions.